I say, if the leaks coming from the pressurized gas at these facilities, any chance of sparks will create a fire explosions like this and getting bigger and bigger, and finally nothing left at all except three words: that's profits loss and also company reputations is at risk. So this is all happens because of the hydrocarbon leak in our facilities. So our innovations is to create the methods called DEWA, which can reduce the number of hydrocarbon leaks in our facilities and have saved the company financial loss up to 45 million US dollars. We are FT-proof supersonics from Pertamina, Indonesia. Pertamina is 100% owned by the governments of Indonesia, and currently we are one of the largest oil and gas companies in our countries. And our operations is located at the north sides of capital city Jakarta, which we operate both onshore and offshore facilities with current productions is 36,000 barrel oil and 157 mm scaf gas. Our project is located at Bravo flow stations, which is one of high producers area in our companies.
To ensure sustainability of Bravo production, we address and solve Bravo problems using PDCA cycles. The cycle approached by 8 comprehensive steps and supported by quality tools and also international standard as a technical references. So for the beginning in project selection, this is ASTRID, stands for Asset Integrity Data Management System, a software application to collect, calculate, and mapping asset condition from all of our field, including Bravo field. So from ASTRID, we found 4 major problems on Bravo field. The first one is hydrocarbon leak on pipe oil joint of gas lift compressor system. The second one is lack of integrity of pressure vessel. The third one is damage on riser of transport line. And the last one is corrosion under insulation of fuel gas system. By calculating their potential losses, and then we compile it into data analysis and problem selection using Pareto, we found that hydrocarbon leak on pipe oil joint of gas lift compressor system has the highest percentage number, which is 72%. So we decided to solve this problem as our project. This project aligned with our company's goals, especially on safety and sustainability, and also on human capital development. By reducing number of leaks, reducing maintenance costs, and eliminate unplanned shutdown, it will be make high impact to our company's goals. Our project objective divided into 5 aspects of QCDSM. From quality, we will improve the lifetime of pipe oil joint to make sure we can meet with the next replacement schedule. And from cost, we will prevent company losses up to $600,000. And from delivery, we will complete this project within 3 months. From safety, we will reduce hydrocarbon leak to avoid potential catastrophic accident. And from morale, we will increase safety index of our employee to improve productivity.
As we mentioned before, that the problem at Bravo Blue Station is occurred at the gas lift compression system. We can compare this gas lift compression system with the cardiovascular system in our body. Imagine that the heart is the compressor which pumps the gas lift, and then the arteries is the piping system which transfer the gas lift. If this piping system is failed, then everything will stop working. The veins is the crude oil which is flowing back up to the surface and complete the cycles. Bravo flow station oil production is mostly supported by the gas lift systems. So 80% of oil production will be stopped if there is any interruption to the gas lift systems. We have performed root cause and effect analysis to identify all the possible causes of this problem by considering material, machine, method, man, and also environments. And we validate all of these possible causes by conducting field observations, from which it is converted to 3 possible causes. And by doing Pareto to the failure mode in effect analysis, risk priority number, we conclude that the pipe well joint susceptible to acid fluid tag is the main root cause of this problem by 71%. According to our record, there have been 22 leaks occurred at the well joint of the gas lift compression systems with caused by CO2 attacks. Now let me watch this animated video right here. From this video, we can see that the chemical reaction between CO2 and water will form carbonic acids, and this acid will attack the well joint of carbon steel based materials. Unfortunately, our piping steel material were made from carbon steel, which one was considered as suitable material for the condition long before the CO2 content increased due to the alter of hydrocarbon source.
So we use 3 steps to develop our solutions. First is to do the brainstorming in internal team, and later we have developed our criteria based on our needs, and finally it will be reviewed again the management's point of view for their expectations and also approved as a final solutions. So we have developed 4 solutions. The first solution is to replace the pipe using a stainless steel duplex, and the second solution is to apply the internal ceramic lining inside of the pipes, while the third solutions will be replace the pipe using a thicker carbon steel materials. However, those 3 solutions is require plant shutdown for their implementations, so it will interfere the production sustainabilities. So we developed a brand new methods called DEWA, which can improve the existing pipe well joint without interferes the productions. So based on the comparisons data, we could see that our methods have ultimate advantage rather than the 3 other solutions. So later, the solutions is reviewed against the management's point of view, and it is found that all the criteria has been met, and this is approved as a final solutions. So, ladies and gentlemen, DEWA, as we call DEWA in Bahasa, stands for detections of welding defect, evaluations of inspection results, and wrapping applications. So these are combining the technical knowledge of 3 different techniques. As you can see here, the pipe replacement is scheduled in the next 2 years. But because of the internal corrosions at pipe weld joint, the pipe will fail before its replacement schedule takes place. In its cause, a potential lost productions and also potential to catastrophic failure, as nobody wants that to happen. So what DEWA method can do is, we are prolong the pipe remaining lifetime, so it will meet the scheduled shutdown safely, and also we can even make the scheduled shutdown become more flexible, as we can predict the remaining pipe lifetimes. So the detections of welding defects is conducted to replace the conventional inspection technique using advanced inspection techniques. As a result, the weld inspections become more accurate and faster. While the evaluations of inspection results, we are predict the pipe remaining lifetimes. Once we found that the remaining lifetime is less than 1 year, we will do the strengthening applications using wrapping applications. So our innovations in this stage is to develop the new specifications of high pressure wrapping applications, which can be applied in 700 PSIG's internal pressures. So those combinations and improvement on each steps has make our solutions become more suitable for these projects. So we have develops our solutions by incorporating the ideas taken from the stakeholder, which is internal and external stakeholders. From externals, the contractor is provide idea about using a wheel rope at the phase array inspections, which can increase the inspections productivities. While at internals, the production team is provide idea using a traceability numbers at the wrapping applications, while the other stakeholders is support us in the project's executions. So those ideas have been absorbed and making our methods become more powerful. So we have developed our plan based on 5W and 2H, which we can address all the step of works, locations, and also responsibilities corresponding to their step of works. So DEWA method has been implemented at Bravo flow stations and has brought a valuable saving, since there were 12 potential leaks have been addressed and have been strengthening using wrapping applications. Monitoring also have been done for 6-month periods so that the pipe weld joint is still safe to operate. We have completed our projects 2 weeks earlier than our plan because of using rope access technique at inspection stages, which can cut the project's durations. So here is for the project result.
Okay, as a functional team which is responsible to the integrity of the facility, we have successfully kept the hydrocarbon inside its containment, which means zero leaks after the implementation of this method. And also, this innovation has successfully reduced the risk priority number of the root causes by 95%. Impact to the organization goals: from safety, zero leaks means our facility are safer to operate. And from sustainability, no interruption to the process means we also contribute to the oil production target of our company. And we saved maintenance costs up to $1.2 million. From human development, this innovation increased the competence level of the peoples. Tangible benefit: from quality, we were able to extend the lifetime of well joint by 5 years. And from cost, we prevent company losses up to $3.7 million. From delivery, this project is finished 2 weeks earlier from our targets. And from safety, we were able to reduce the hydrocarbon leak by 100%, meanwhile we aim to reduce the hydrocarbon leaks by 50%. And from morale, it is observed that 97% of the surveyed employees are satisfied with these innovations.
This is intangible benefit of our innovation. Dewa method is a brand new method in Pertamina. And this method also increased personal competencies, especially on advanced inspection technique and also on high pressure wrapping application. We have recognition from international and international, such as from the Welding Institute, United Kingdom, and also from Shell, Malaysia. And this method also contributes to many other company achievements. We have standardized these methods as default integrity management method in our company and have been uploaded to Pertamina's knowledge management system, so everyone in our company can learn about this innovation. Moreover, we have registered this method to Indonesian Ministry of Law and Human Rights and already have a copyright for this innovation.
So the project has been replicated in the 5 other areas in our companies. So as you can see here, it has saved by more than $45 million, which is a really huge money. And we also have shared these innovations in internals and also in externals recently at the SPE conference in Kuala Lumpur and also in Aberdeen, United Kingdoms. So we are, as part of the continuous improvements, we will overcome the problem of lack of integrity in pressure vessels at Bravo fuel stations. So to ensure that the team member can work effectively, we have detailed the step of work and also responsibilities corresponding to their technical knowledge. And moreover, we have developed the communications plan and weekly meeting and monthly management update to ensure that the projects can be delivered on time, on budgets, and on scope. So that's all for our presentations. Dewa method is now becoming an asset of our company, and it is a proven tool to reduce the number of hydrocarbon leaks in our facilities. Thank you very much.